Now we are going to discuss about evaporation and evapotranspiration. Evaporation and evapotranspiration are two of the most important and complicated phases of the hydrologic cycle. So what is the purpose of this evaporation rate? What is the need to estimate the evaporation rate? So this evaporation rate is used in the design of reservoirs, irrigation systems, scheduling and frequency of irrigation, and water balance and simulation studies. What is evaporation? What is evapotranspiration? Evaporation is the process by which water from liquid or solid state passes into the vapor state and is diffused into atmosphere. And then this is also evapotranspiration is as like as evaporation, but here the water evaporated from the soil and also evaporated from the plant. The combination of these two is known as evapotranspiration. So to continue the evaporation, they should need, one is supply of water, another one is source of heat and vapor pressure deficiency. If these three are available, then only the evaporation will continue. Then what are the factors affecting evaporation? The main factors are, one is vapor pressure, temperature, wind, atmospheric pressure, soluble salts, heat stored in water bodies, size and shape of water surface and nature of surface. Right? Vapor pressure. So what is vapor pressure? The rate of evaporation is proportional to the difference between the saturated vapor pressure at the water temperature and actual water pressure in the air. Then the rate of evaporation EL equal to C into EW minus EA, where C is the constant and EW is the saturated vapor pressure of water temperature and EA is the actual vapor pressure at 2 meters above the water surface. 2 meters above the water surface. And then the evaporation continue up to EW, that means saturated vapor pressure is equal to the actual vapor pressure. If saturated water pressure is more than actual water pressure, there is no evaporation, condensation will be takes place. Then temperature, this is another factor. This is known to all, that the temperature increases, that evaporation rate also increases. And atmospheric pressure, here the atmospheric pressure based on that also varies from with respect to level. In high levels, high elevations, the atmospheric pressure, the barometric pressure reduces automatically. In that situations, the evaporation rate will be increases. And next one, soluble salts, where the soluble salts are added to the water, then the evaporation rate is reduced. And heat stored in the water bodies, that the deep water bodies have more heat stored as compared with the shallow water bodies. That's why in summer season, in deep water bodies, that evaporation rate is less as compared with the shallow water bodies that are exposed to in the same area, same zone. And size and shape of the water bodies, if the surface of the water body is in plane surface having some different evaporation rate, if the surface of the water body having convex shape having different evaporation rate. In case of convex water bodies, the rate of evaporation is higher as compared with the plane surfaces. And then wind. Wind also affects the evaporation rate. Up to certain limit, the wind increases parallelly. The evaporation rate also increases on reaching on critical velocity, critical speed. Then again the evaporation rate decreases. Then evaporation and estimation of evaporation. So these two are the important heads in the hydrological studies. The evaporation is estimated by using evaporimeters and empirical equations and analytical equations. So what is evaporimeter? Evaporimeter are the water containing pans which are exposed to atmosphere, and the loss of water by evaporation measured in them at regular intervals. This evaporation pans also used to measure the meteorological data to determine that to identify the meteorological data that are humidity, wind movement, air and water temperature and precipitation. And important types of evaporimeters are US Class A evaporation pan, Colorado sunken pan, US Geological Survey floating pan and ISO standard pan. Estimation of evaporation. Here by using these evaporation pans, the evaporation rate is different as compared with the actual evaporation from the river or the reservoir, because the evaporation pan size is very less as compared with the actual reservoir size, so that the evaporation rate is more in case of evaporation pans as compared with the reservoir. Because of, and one more point is, the evaporation pans are prepared or manufactured with the metal and the exposed area is very less as compared with that reservoir. That's why the rate of evaporation in case of pans are high as compared with the lakes. To calculate actual evaporation from the reservoir or the lake, we have introduced one more term that is known as pan coefficient. Pan coefficient is the ratio between the evaporation from the lake or reservoir to that of the evaporation from the pan. Right? This is the definition. Here, the pan coefficient values are also different from different pans. Here, US Class A pan, the pan coefficient value is 0. IS standard pan 0.8 and US Class A pan is 0.7 and Colorado pan is 0.7 and Geological Survey floating pan is 0.8. Therefore, finally, actual lake evaporation equal to pan coefficient, that is different from different pans, and pan evaporation. This is about pan coefficient for the determination of actual evaporation rate from the reservoirs or the lakes. And then empirical formulas. These empirical formulas are as like as Dalton equation, that is already we discussed earlier, that the Dalton equation, this is the Dalton equation, you know the evaporation rate is equal to some constant into saturated vapor pressure of the water temperature minus the actual water pressure. Evaporation from lakes and reservoirs is usually estimated by empirical methods based on the meteorological data. These empirical methods are as like as Dalton's equation. For the determination of evaporation rate by using these empirical methods, we should use the meteorological data, but in the case of these empirical methods only use one or two meteorological factors, because this empirical method is a very approximate method. This is one formula, empirical formula, that is the Lake-Hofmann formula. Here Lake-Hofmann formula, this evaporation rate E equal to 0.097 ES minus EA. This is as like as earlier formula. Here ES is nothing but saturated water pressure at water temperature, and E8 is the actual water pressure, vapor pressure in air. V is the velocity of wind, that is 8 meters from the water surface. This actual vapor pressure in air is also 8 meters above the water surface. And one more formula, that is Mary's equation. This is also used for the estimation of evaporation rate. Here E equal to C into ES minus EA 1 plus 0.06215 V9. Here this is also as like the earlier formula, only that difference is 8 meters, here 9 meters above the water surface. Remaining all are same terminology here. And last one, evaporation from the soil surface. So already we estimated the evaporation from the water surfaces. We have different methods for the estimation of evaporation from the water surfaces, that are the empirical methods, evaporation methods. But the water surface evaporation is, compared with the soil evaporation, is a little bit more. Evaporation from the soil surfaces, the rate of evaporation from the fully saturated soil surfaces is approximately equal to that from the equivalent free water surfaces, but this is not strictly speaking, this is not equal. In general, the evaporation from the soil surfaces is less. It depends upon the type of soil and evaporation opportunity. Here, the evaporation rate from the water surface is different from evaporation rate from the soil surfaces. So, to calculate actual evaporation from the soil surfaces, here introduced one term, that is evaporation opportunity. Evaporation opportunity is the ratio between the evaporation from the soil surface to that of evaporation from the water body or water surface. Right? The evaporation opportunity is measure of the possibility of occurrence of evaporation from the soil surfaces. The analytical method, these are the last one. Analytical methods are water budget method, energy balance method, and mass transfer method. So these three techniques are used in case of analytical method. Transpiration and evapotranspiration. Now already we discussed about evaporation. Evaporation means the water evaporated from the moist soil and water bodies. Here transpiration is the process in which the water being lost from the leaves of the plant, of their pores. Right here, that means the water evaporated to the atmosphere through the leaves of the plant, pores of the plant, then that is known as transpiration. What are the factors affecting the transpiration? That are atmospheric vapor pressure, temperature, wind, light intensity, and characteristics of the plant such as the roots and leaf system. Right. Transpiration is essentially confined to day hours only. That means for the for the conduction of the transpiration, they should need light. That's why the transpiration is continued only in day hours. Whereas in case of evaporation, that will continue day and night hours. Next one is the evapotranspiration. Evapotranspiration is the combination of evaporation as well as transpiration. Here where we are having one plant, that plant should have surrounding soil. The soil having some moisture. The water evaporated from the soil as well as from the plant. That system is nothing but evapotranspiration. Here, when the transpiration takes place from the plants in the field, the surrounding soil also leaves water by the evaporation. Evaporation is the sum of total water transported and evaporated from the adjacent soil. Right? This term, evapotranspiration, is also known as consumption use or potential evapotranspiration. Here, in this regard, evapotranspiration, we should learn two heads, that is potential evapotranspiration as well as actual evapotranspiration. What is potential evapotranspiration? If the sufficient moisture is always available to completely meet the needs of the vegetation for covering entire area, is known as potential evapotranspiration. Potential evapotranspiration. If sufficient moisture is always available to completely meet the needs of the vegetation, the resulting evaporation is known as potential evapotranspiration. This is denoted by PET. Actual evapotranspiration, this is nothing but real evapotranspiration occurring in a specific situations is called actual evapotranspiration. To differentiate these two heads, PET and AET, we should know the two terms, that is, one is field capacity and another one is the permanent melting point. What is field capacity? Field capacity is the maximum quantity of water that soil can retain due to force of gravity. If any additional water added at this condition, that is simply drained out. And next definition is permanent melting point. Permanent melting point also moisture content of the soil, but this moisture content is not useful to sustain the plant growth. At this stage, even though the soil contains some moisture, it will be so held by the soil grains that the roots of the plant are not able to extract it in sufficient quantity to sustain the plant growth. And the difference between these two moisture contents, field capacity as well as permanent wilting point, is called the available water. That moisture is available for the plant growth. And variation of AET with respect to PET. Right? Actual evapotranspiration with variation of potential evapotranspiration. Right here, if the sufficient quantity of water or the water supply to the plant is adequate, the soil will be at the field capacity. At this condition, the AET will be equal to PET, because here the sufficient quantity of water available for the plant growth means the moisture, the soil is at fully saturated condition, that is having 100% of quantity of water. At that situation, AET will be equal to PET. You know what is the definition of PET? PET means that maximum quantity of water available to sustain the plant growth, that is nothing but PET. Actual evapotranspiration here AET. Here AET is equal to PET means the sufficient quantity of water available in that condition. The next one is if the water supply is less than the PET, that means the sufficient quantity of water is not available to sustain the plant growth. At this condition, the actual evapotranspiration should be less than the potential evapotranspiration. Right? The decrease of the ratio AET by PET with available moisture depends upon the type of soil and rate of drying. Before going to type of soils here, AET by PET discussion, here we are going to take two soils. One is sandy soils, another one is clayey soils. In case of clayey soils, the moisture content is fall down up to 50% even though the AET by PET ratio is constant. Whereas in case of sandy soils, the water content reduces at 10%. The AET by PET ratio graph is varies. Just you see the diagram here. This is the one is sandy soil and another one is clayey soils. Here this is the AET by PET ratio. This is a percentage of available moisture. In case of clayey soils, the moisture content is reduces 50%. Moisture content reduces 50% even though the AET by PET ratio is continue up to this. Beyond the 50%, the water content reduces, then the graph will be fall down. That is in case of clayey soils. Whereas in case of sandy soils, this is the 100% of moisture content gradually reduces 100 to 80, 60, 40, 20. But here starting onwards, once the moisture content decreases, the graph also AET by PET ratio also decreases. This is the difference between sandy soil and clayey soils.